Today we will look at the basic implementation of stack data structure using C programming language. To implement the stack data structure, it has to support at least a minimum of the following functionalities. These functions will be useful in solving programming problems which needs stack data structure. Of course, you can expand the functionality of the stack data structure by implementing more functions, which might be useful in a particular programming problem. Here we are just trying to teach you the basics so that you can tweak it as per your programming needs. The basic operations that a stack must support are a function to create the stack, a function to destroy a stack, and of course the functions to push and pop an element to and from the stack. And some special operations which are needed most of the times are top function, isEmpty function, and isFull function. The top function can be used to take a look at the object sitting at the top of the stack without popping it. It is effectively like pop an object and push the same object to the stack. The next function is isEmpty. As the name suggests, isEmpty function can be used to check if the stack is empty or not. This can be used to prevent stack underflow as we discussed in our last tutorial. And the last function is isFull function. This function can be used to check if the stack is full. This can be useful in the prevention of stack overflow. In the previous slide, we saw what and all functionalities we will be implementing in this session. These functionalities will be available to the end user of this data structures. But the internal implementation of the stack logic is up to us. To implement the functionalities, we have to first think of a way of saving the object which the user will push into the stack. Various data structures like array or linked list can be used for that. Here in this tutorial, to keep the implementation easy, we will be using normal arrays as shown here. We can look at the linked list in the future when we discuss about them. As we all know, the arrays are of fixed size. Hence, the stack which is implemented on top of it will also have a limitation of maximum number of objects that it can hold at a time. Of course, using malloc and realloc, this limitation can be overcome, but we will not be discussing that here to keep this simple. This is how the backend of the stack will look like. The stack grows from the index 0 to max size of the array. If you tilt your head to the right, this array looks like a jar which we used in our previous tutorial. Based on this assumption, we will start the implementation of the functionalities that we decided in the last slide. Okay, let's look at some basic declarations which we will be using during the implementation. The data type here represents the type of the object which the stack will support. This can be changed to support a different type of data type as needed. Then we define values for two exceptions, stack overflow and stack underflow, so that the code using the stack can be notified about the exceptions. And for clarity, we define two macros for success and failure cases. The next one is the structure which will be used as an anchor to keep the data related to the stack together in one piece. It contains three fields. First one is the pointer to the memory, which will be used to save the objects which are pushed onto the stack. The next variable is the size of this memory to prevent stack overflow or memory overflow. And the last one keeps track of the index in the array where the top of the stack resides. In the next few slides, things will be more clear when these fields are used in various functions. We will start with the stack creation and destroy function. The first thing to be done while creating a stack is of course to allocate space to save the objects in the stack. To allocate space, the function should know the size of the stack which the user wants to create. That's why this function takes size as a parameter. The first parameter is the stack anchor which the user will use for all the operations. So we first do a malloc of the size that the user requested for. If malloc fails, obviously the stack creation will also fail and we return with an error. If malloc passes, then we initialize the size of the stack in the anchor for future users. And since there are no elements on the stack as of now, the top of the stack is initialized to -1 and we return with success. The destroy function is very simple. Just free the memory allocated for the element and initialize the value of max size to -1 so that we don't perform any operation on this freed stack. The next ones are push and pop function. As we all know, push operation means to save the element on the stack. Both the stack anchor and the element to be pushed are passed as a parameter to the push function. Now before pushing the element onto the stack, we have to make sure that there is space in the stack for the new element. The top underscore index is the index where the current top of the stack resides. And we know the size of the stack, which is saved in the max size field. Since the array index in C starts from 0, the maximum value of the index in the array is max size -1. So if the top of the stack resides in max size -1 index, that means the stack is full and it will lead to stack overflow. This if statement will take care of the stack overflow. If there is space, then increment the index of the top element and save the object in that index and return with success. Now since top underscore index contains the index of the new element that was pushed onto the stack, this new element becomes the new top of the stack. Now let's look at pop function. As we know, in the pop function we are supposed to retrieve the object sitting at the top of the stack. The index of the top of the stack is saved in top underscore index. But before we pop the topmost object, we have to make sure that there are some elements in the stack. If there are some elements in the stack, then top underscore index should not be -1, which is an invalid array index. Hence, we first check if top underscore index is -1 or not. If it is -1, then it means there are no elements in the stack and it will lead to stack overflow. If it is not -1, then we can read the element from the array using the index of the top element. Since we have popped an object from the stack, we need to decrement top underscore index by -1 so that top underscore index points to the next element in the stack and we return with success. Now let's look at some simple functions which can be used to perform some special operations on the stack. The first function is top. This function can be used to look at the top element in the stack without popping it. The logic for this function is same as a pop function, but here we don't decrement top underscore index field, which prevents the pop of the element. The next function is full. This function can be used to check if the stack is already full or not. This can be used before the push operation to prevent stack overflow. The logic is simple. If top underscore index, where the top element is sitting, is equal to the index of the last element in the array, that means the array is full and hence the stack is full. The index of the last element in the array is max size -1. If they are equal, return with true, else false. The next element is empty. This is also very simple. If there are any elements in the stack, then top underscore index will not be -1. Hence, if top underscore index is -1, that means stack is empty, so return true, else return false. Thank you. Do visit us at mastgyan.com for more videos.